All right, we're now going to talk about seasons and why we have seasons. All right, so we know that the sun changes its declination throughout the year from negative 23.5 to 23.5, which means where the sun is in the sky changes by 47 degrees everywhere on the earth. It doesn't matter where you are, it's just where that 47 degrees is in your sky is determined by your latitude. All right, so you're probably wondering why we did these Herb diagrams, why we care about where the celestial equator or the altitude of it is. Well, the reason for that is because from there we're going to figure out where the sun is. So, back to our Herb diagram. North, south. I'm going to draw coordinate lines on the grid, east, west. And again, we're going to do it from Commerce. Remember, you can adjust it for any latitude you want. And you will in the homework. All right, so first thing we do, always do, is we say, oh, okay, this is 33 degrees. Here's the North Celestial Pole. Remember, that angle always equals your latitude. And then we go, from there, we go 90 degrees, so that's a 90-degree angle. And that's the celestial equator. And it's actually a circle. What we usually do is just mark where it crosses the meridian because we care about the highest point. Okay, and we figured out for Commerce that this angle, or the altitude of the celestial equator, is 57 degrees. When you draw pictures for your homework and on the test, make sure you label all these. If you don't label them, it's going to be automatically wrong even if you have the right answer. You got to draw accurate pictures. I have students that'll do stuff like this, and they want me to give them credit for that. So I can't give you any credit because I have no idea what kind of hieroglyph you were trying to write. So make sure you label it and make it accurate. All right. We figured out that the sun, right, is going to change its declination throughout the year. So remember, these are the north and south celestial poles. This is the celestial equator. And we had to put in the ecliptic, or the path of the sun, and it has this 23.5-degree tilt. Up here is the summer solstice. The declination of the sun is 23.5 degrees. This is negative 23.5 degrees on the winter solstice. Winter solstice. The vernal equinox is 0. The autumnal equinox is 0 for the declination of the sun. All right, so what I want to do is figure out the maximum and minimum altitude of the sun from Commerce, Texas. This is not hard because we know the maximum occurs, since we're in the northern hemisphere, it's going to occur when the summer solstice occurs. Summer solstice occurs, the sun is at a declination of 23.5 degrees. Don't forget what declination means. Declination means the sun is 23.5 degrees above the celestial equator. So here's our celestial equator. So the sun is 23.5 degrees above it. The sun is up here. This is the sun on the summer solstice. And I can draw a line there, and this angle here is 23.5 degrees. That's the maximum altitude the sun gets. Well, the sun's altitude, remember, is measured from the horizon. So what we really need is just this whole angle right here, from here all the way to here. Or it's just going to be 57 plus 23.5, or in this case, 80.5 degrees. So the sun gets up to a maximum altitude from Commerce. If this is south, it gets up to 80.5. It never gets directly overhead. It gets close. It gets within 9.5 degrees, but it never gets directly overhead from Commerce, Texas. Now the minimum is when the sun is down here. This is the sun on the winter solstice. In this case, the angle is also 23.5 degrees, but it's 23.5 degrees below the celestial equator, so we just subtract it. So this is 57 minus 23.5 degrees, which is, make sure I do my math here, 33.5. Did I do that right? All right. You can always check yourself. Because look, it's 23.5 above, 23.5 below. So if you add that together, 23.5, 23.5 is 47 degrees. Those have to be exactly 47 degrees apart. Everywhere on the earth. So for us, the sun goes from an angle down here up to here. From winter to summer. Let's also look at the path of the sun. Notice that the sun here in the summer, it's going to stay that 23.5 degrees above the whole time, so it's going to make a path that goes like this. It's going to rise over here in the northeast and set in the northwest. And it's going to make a very big loop in the sky. In the winter, it's going to go from below to below, so it's going to rise in the southeast and set in the southwest. And so this is less than half a circle. This is more than half a circle. And though on the equinoxes, the sun is exactly on the celestial equator. So that's why in the winter we have the shortest days, because the path of the sun is the shortest in our sky. And in the summer, the path of the sun is the biggest in our sky, so it's up for the longest amount of time. We have about 14 hours of daylight in the summer, 12 hours on the equinox, and we have about 10 hours in the winter. The further north you go, the more extreme that becomes. Okay? And I'll show you that in just a second. We'll go to a very extreme case. But hopefully this is making sense. The key here is always find, this is the altitude of the celestial equator. So that's why we spent that time figuring out what the altitude of the celestial equator is, because once you have that, to get the maximum of the sun, you add 23.5. To get the minimum, you subtract 23.5. Now, if you're a ship captain, back in the days when you were trying to figure out what your latitude was on the earth, you're out there on the ocean, what you would do is you would take your sextant and you would measure the angle to the sun exactly at noon. And once you knew the angle of the sun, you could then work backwards, saying, oh, on this day the sun's declination is this. You work backwards, you find the celestial equator. Once you find the celestial equator, you go to the north celestial pole, and you figure out what this angle is, and you figure out your latitude. That's what the ship captains did back in the day. Nowadays you have GPS, and it just tells you exactly what your latitude is anywhere on the earth. But before, when they had to use the sun, or they could use stars, they had to use something they knew the declination of. Once they knew the declination of it, then they could work backwards from its altitude to figure out what the latitude was. All right, let's do a case where it's a more extreme case. So we're going to figure out the altitude of the sun. But we want to do it for somewhere like a latitude of 66.5 degrees north. All right. 66.5 is a very special number, and I'll show you why. So what we're going to do is we're going to do the same thing. I'm going to draw a Herb diagram. I'm not going to do it three-dimensional, because you don't have to draw them three-dimensional. Just do the 2D drawing. North-south, Herb is here. Now try to draw these angles accurate. You don't have to use a protractor, but 66.5 is going to be a pretty big angle. So right up here, this is going to be the north celestial pole. That angle is 66.5. Remember, that's always equal to your latitude. And then from there, I'm going to go 90 degrees. Okay. And that's going to be the celestial equator. That's how you start out all these problems when you're trying to find the maximum or minimum altitude of the sun. Okay? Then we say, okay, where's the sun at its maximum? Where's the sun at its minimum? But before I do that, I need to know the altitude celestial equator. I need to know this angle right here. Well, to get that angle, I know this is 180 degrees, so I just take 180 minus 90 minus 66 and a half, and I get it's equal to 23 and a half. Okay? That's why this is a special point. I picked it deliberately so that that altitude celestial equator is 23 and a half. Now remember, to get the altitude of the sun, we take the altitude of the celestial equator, the maximum, we just add 23 and a half, because the sun is going to be up here. Here's the sun on the summer solstice. And I add 23 and a half, 23 and a half, 23 and a half is 47 degrees. Okay? The minimum is going to be equal to 23 and a half minus 23 and a half, or 0. Which means the sun on the winter solstice is right here, 23 and a half degrees below. Which means on that day of the year, December 22nd, if you live at a latitude of 66 and a half degrees, you get no sunlight. The sun never rises. And you get one day of no sun at all. That's why we have a special name for this. This latitude is actually called the Arctic Circle, because it's a very special spot.